Bismillahirrahmanirrahim. Welcome to Beingguruelectrical channel. This is Mujib Reza with you PLC programming course in the new class. Today we'll discuss PLC programming languages. Before going to start the video, if you are new on the channel, subscribe and turn on the notification to receive our course updates. And if you like the video, so like and share with your friends. So now let's start. PLC programming languages. The term PLC programming languages refer to the method by which the user communicates information to the PLC. So what is programming languages? The programming language is the language through which we can communicate with the PLC, by which we can communicate with the controller. So there are three types to communicate with the controller. The one include the most common used is the ladder logic or ladder diagram language. The second one is Boolean language, and the third one is functional chart language. The most commonly used is the ladder logic. So the three most common languages structures are ladder logic, Boolean language, and functional chart. If we see this ladder logic, in this we have NO contacts, NC contacts, and output coil. While in this Boolean language we have instructions. This language is also called instruction language because we write instruction in this. If you see this start means when you write start in the Boolean language, it means initiate the program. So push button 1 will end with CR1. So these two input will end and the output will OR with LS1, and then this output will end not with CR2, and it will again this result will come to the output. So this we will discuss in detail in the future classes. So be with us until we reach there. The functional chart it acts as the instruction 1, instruction 2, instruction 3, then end. So this is not commonly used. Anyhow, we will see this also in when we program on the software. So this we will see later. Okay, now we will compare how we can make programming in different languages. Okay, first we have relay logic diagram. It's called relay schematic or relay logic diagram. We have one push button PB1. We have control relay CR1. Push button is normally open. Control relay contact is normally open, and it is connected with parallel with limit switch 1, and it's in series with CR2. NC contact normally closed, and it is connected to the output solenoid coil. So this is the relay schematic. The equivalent of this in the ladder logic will be like this. So the main reason why the ladder logic is very easy and very convenient for the programmer, because it resembles with the relay schematics. If you see this, these are similar. So in the ladder logic, what we will do, this push button will be replaced by NO contact. This CR1 NO contact will be replaced by CR1 NO contact. This CR2 NC contact we will mention CR2 NC, and limit switch NO contact will be replaced by LS1 NO contact. So an output solenoid will be replaced by output coil. So this is equivalent ladder diagram to this relay schematic diagram, which is very easy. Same this example, if we see in the equivalent Boolean language, how it will be like. We have this push button 1. It is for this Boolean language you need to understand the AND gate, OR gate, NAND gate, XOR gate, then you can understand this Boolean language. So if you see this, these are in series. So for the series we make end. So start is the initiation for the program, like we are here. From here if we mention start, so we have push button 1, so what we will write pb1. pb1 refer to this switch. Now this is in series with the cr1, so pb1 we will mention and cr1. So what it represent, push button 1 is and with cr1 because it is in series. Now these both are parallel with ls1, so the output will come here, and this output is OR with ls1. Understand? This is parallel, so for the parallel we use OR gate. So output here is OR with ls1. ls1 is here. So now we reach here. Now this result is now we reach here. So this result is now we have NC here. So we will mention AND NOT gate CR2 and not CR2, this result and not CR2. And now we reach here, so we mention out. So this is our solenoid output. So this is all about different language when you compare the Boolean language and ladder logic. Okay, next we have relay type instruction. Relay type instruction, the ladder diagram language is basically a symbolic set of instructions used to create the controller program. What is a ladder diagram language? It is basically representation of NO contact, NC contact, and output coils, timers, counters. And what it represent? It represent a set of instructions. These ladder instruction symbols are arranged to obtain the desired control logic. We only play with NO contact, NC contact, coil, timers, and we get our desired output from this. Now see this is called examine if closed instruction. This is the symbol and analogous to the normally open relay contact. Like for the normally open in the programming or the PLC programming language, what we call this, examine if closed. Normally open relay. For this instruction we ask the processor to examine if the contact is closed. For this we ask the processor to check, to examine if the contact is closed. Typically represent any input, can be a switch or push button. It can be switch, it can be push button, a contact from a connected output or a contact from internal output. It can be anything. Has a bit address which is examined for an on condition. It is examined for the on condition. If it is closed, it will pass the signal. The status bit will be either 1 or 0. It will be either 1 if closed, if open it will be 0. Now see, examine if closed instruction, how it works. We have I:012 memory register. Now this memory register you can understand only if you check the previous classes. We discussed the memory registers, we discussed the input data table, output data table. So in the input data table we have this memory register I:012, and I:012 bit number 4 is represent the status of this switch or this NO contact. So examine if closed, what is represent here is 1, so this is closed. See here, now we will check examine if closed instruction. We have I:012 data register. At the 04 bit we have the data for this bit, either it will be 0, either it will be 1. If the bit is 0, 0 mean off. If the status bit is 0, what will happen? Then the instruction is false. Like see here, if this is 0, it will be off or it will be false. Now on the contrary, if the status bit is 1 or on, then the instruction is true. If this is closed, if this is examined and it is closed, what will be here? Here we have 1. Okay, if this is closed, here we have 1, so our instruction is true. Examine if open instruction, what we already discussed. Examine if closed. Now we will see examine if open. Analogous to the normally closed relay contact, it is same like normally closed contact if we compare it with the relay schematic. For this instruction, we ask the processor to examine if the contact is open. What we ask the processor to examine if the contact is open. So the status will be either 0 or 1. Typically represent at any input, can be a switch or push button, a contact from this is only like, it may be output from a switch, it may be output from a push button, or it may be this contact of the another output. It can be anything. It has a high bit address which is examined for an off condition. This is the same as we discussed in the examine if close instruction. Now see here, examine if open instruction. We have I colon 12, bit number 4 is representing the input data of this contact. So if this status bit is 0, if this is 0, what will happen? It will true, the condition will true, or the instruction will true, it will pass the signal. On the contrary, if this is 1, mean it will be, the condition will false and it will be open, so the instruction will be false. Here 1, we have false condition. We talk about the input. Now check the output. Output Energize OTE instruction. Analogous to the relay coil, the processor make this instruction true. This is analogous to relay coil in the relay schematics. The processor makes this instruction true when there is a path of true examine if closed and examine if open instruction in the rung. If examine if closed and examine if open instruction are true, this will also be true. So it depends on the input. The status of this output depend on input. Typically represent any output that is controlled by some combination of input logic, can be a connected device or an internal output, internal relay. So this is controlled by input logics. If any left to right path of input condition is true, the output is energized. If from left to right we have a complete loop, or our path is complete, input is true, so the output will be true or on. Now see here an example. We have I colon 012 and O colon 013. This you can, if you didn't understand this, I will recommend you to go back and check the previous videos, because if you didn't understand this memory register, you cannot understand this. Okay, I colon 012 is the input memory register, and this is the output register. So 11 refer to this switch status. We have here 11 and we have 15 here. So this is 1, this is 1. What will happen? This is normally, okay, we have ladder logic. At 11 we have NO contact, 15 we have NO contact, and we have output coil 01 with the location 01 here. Okay, now see, if now we can see here our input is high, input is also high or true, so this is okay, this is high, this is high, so the output is high. We can see here the output is high. This is because the input logic from left to right is true. This input logic is true, so the output is true. Now see the other condition. If any, because this is a continuous series, if any of this switch is open, the output will be false. Like see here, bit number 11 is 0, so this is open. Even bit 15 is closed, but this is open, so the output will be open. See, the output is condition is instruction is false. Now status bit example. Status we can make inside the PLC, like if you want to make some LED on or off, so we can make this. We can make by push button or by taking some limit switch or anything you can take. So status bit example, if we see, we have push button or switch which is connected to the input module, and output we have 1 bit status. So let's see button not, if this but switch is not actuated, what will happen? We have NO contact, so switch is open, so this is open, so output is off. Now if we have NC contact, if this is open, it will be true and the output will be on. Okay, this is open, so the NC will be on and the NO contact will make the output off. So this is on, this is off. Now see the other condition. If this is closed, button is actuated, so the output status is 1. So what will happen? The NO will be true, NO contact A will be true, and the output will be on. In this case, button the NC contact will false, as this is closed, and the output will be off. So this is the status bit examples in the PLC. Ladder rung. A ladder rung consists of set of input conditions. This is the input condition A, B, C, and D. This is input conditions represented by contact instruction. These are the contacts instruction, and an output instruction. This is output instruction. At the end of the rung, represented by coil symbol. This is coil symbol. So the combination of input instructions and output instruction from left to right is called ladder rung. So this is one rung. Okay, now see how the rung operates. If from left to right any of the path is closed, the output will be true. For an output to be activated or energized, this is the output, and if you want to make this output energized, but at least one left to right path of contact must be closed. From left to right, at least one should be closed. Either this will be closed, this A, B, C will be closed, or D and C will be closed to operate the output instruction. A complete path is referred to as having logic continuity. When logic exists, the rung condition is said to be true. Okay, rung continuity. We have limit switch 1, and the bit in the memory, the data for this switch is 1. Like this is normally open contact, and we have in the memory we have 1, so this is closed or true. If this is true, the output will be true. See, in the bit memory is 1, so this is true. The examine if close instruction is true, making the rung true. Same for the close. The examine if close instruction is false, if making the rung false. Like if this is 0, this is open, so the output is false. Okay. Now this is Allen Bradley LHC 500 controller. In this we will see the addressing, how the PLC do the addressing inside. So for this this is output image table, input image table. This is already discussed in the previous video. Okay, we have input, close input, which is NC. It is connected to input module, the address for which is I1:3/12. I:3/12 is here. Okay, so this is like representing this ladder logic. This is user program rung. We have a user program rung, we have NO contact, and we have output coil. So the data of this switch is taking data from this bit, like this close input. We have input connected to this input module, and this input module is storing the data either 1 or 0 in this memory location. So from this memory location, this contact is checking the data, is examining the data. If this is closed or this is high, the output will be high. So at the output location 6, this data is going to store. This is location number 6. Start from 0, 0, 1, 2, 3, 4, 5, 6. So the location number 6, this is high, so 1 will be stored here during one program cycle. The program cycle is also we actually have one lecture on program cycle. So if you didn't check the previous lecture, so you can go there and check the PLC program lecture. I will give the link in the description also. Okay, we have one here. So this one is reflecting at the output module here, and this O colon 0 slash 0 colon 4 slash 6, this output terminal is connected to output, and if this is high, so the output is energized. So this is for the today lecture. I hope you will enjoy it, and if you enjoyed the lecture, like it and share with your friend. And if you have any issue or any question, you can let us know in the comment section. Thank you, and see you soon in the next lecture. Thank you.